Okay, let's see, tulikuwa wapi? Yeah, so tulikuwa like, I was trying to take notes on this. So how do I define a rectangle or a color? I simply call the constructor method or the constructor function within the Pygame class, and then you're able to get, for example, color. Define your color code. I missed this. Same applies to, let me just fix up. We'll do color. So same applies to the defining a rectangle. So you have the x, y. So the x is the top left corner for that rectangle, top left position. Y is the top right position, and then you need to define the width and the height. So that is what I was going through at this point, how to go about defining a rectangle. And right now, I think at this point we've not yet reached there, so right now I'm just like going through some of the constructor functions that I need to know. Yeah, I also wanted to pinpoint how in Python you have a difference between methods and classes. They're quite similar. I mean, it's almost like the same thing, only that methods tend to belong to objects. See, so methods define a specific attribute for a given object. You can say, like, let's say you have an object being a person, and this person has a function walk. So walk in Python will be referred to as a method because it defines or updates a certain attribute of the object. Then you have functions, which are simply normal functions. Then you have constructor functions, which are functions inside. You can call functions inside, like they're simply functions that have the same name as the object. So they instantiate a particular object. Case example is color. This is one example of a constructor function. Rectangle, the same. So when you call them, we're instantiating the object color or rectangle, and then you pass our attributes. So constructors simply define those. So what are the attributes that are accepted, what is not accepted. Let's continue. We have some of the things you can do with the rectangle object once you have it. So it will return a rectangle object. So ideally, what is going to happen is this. We have, so the returned rectangle object has access to a couple of methods, i.e. we can call right, we can call left. So case example, at this point we see we're able to call the right method and set the right position, left method and set the left position. So based on this document, we also need to understand how are these calculated, how the coordinates calculated, because once you set like the top left position, the top left position, that is x, top right position, that is y, we really don't know like how are these calculated. So you can see, if I need to know the x coordinate of the right edge of the Pygame rectangle object, we simply stored in the span the variable just defined. You can access that by using the right attribute. So by accessing it, it will actually tell us exactly the coordinate of that right edge and the left edge, the same case. So the rectangle object automatically calculated that if the left edge is at the x coordinate 10 and the rectangle is 200 pixels wide, then the right edge must be at the x coordinate 210. Oh, okay. So if it's 200 pixels wide and the position is 10 pixels from left, that is x, the top left edge of that rectangle, then you can assume we take that 10, then you add the 200 pixels. That is where we find now the top right edge, that is the y. So that is the the x coordinate, so it's 200 pixels wide. Then we have a coordinate at 10, the rectangle is 200 pixels wide. Then the right edge must be at the x coordinate 210. So we have the right edge, as I said, we have right and left. So the top left corner, then you have the top right corner, then you have width, and then height. So that is how we go about setting or determining the position of the top right or top left edges of a rectangle object. We have other attributes in this list, the value of the height, the width. We can access the center of the x coordinate of the center of the rectangle. You can access the size, which is a tuple of width and height, and that is how we define coordinates in Pygame. So coordinates in Pygame are we can say coordinates in Pygame are, I'll do this. So we are going to say part of our notes. We're going to say coordinates in Python are defined using a tuple, i.e. so a tuple, this example of a tuple tupper xy. So this is an example of how the coordinates of any given pixel is defined in Pygame. So I'm just going to go through and see what cool things are you going to build, because right now it's more of the fundamentals about Pygame, what you need to understand, etc. Then let's see, primitive drawing functions. Pygame provides several different functions for drawing different shapes. So okay, now we have drawing.py, so we are going to try and draw something interesting. This is a new thing, so let's do this. We're going to do let's do this. Let's say new I'm going to say new. I think supposed to do, you can do we can do new and then say drawing.py. You should be able to do that. So we'll go through importing everything. Import Pygame and then the system object. We can say from Pygame dot locals import everything. So I'm going to import everything. Then we're going to now initialize the Pygame instance. So we'll initialize an instance of the Pygame object. So we'll determine our window, which I'm going to say pygame.display.setMode. Provide the width and height. You're just going to do 400 by 300. Then after that, you're going to set the caption. So set caption. You have this. Going to say draw something, right? So going to just say draw something. And then after that, we will write the common things we need to do. So the loop. So this loop ensures we're within the game loop. Then you're just going to say for event in pygame.event.get all events. What do you do in this case? We're just going to check if event.type equals quit. Then we'll say pygame.quit. So you always have to quit the Pygame instance first before we now do the system.exit, because there's an error. That pops up at certain points, so that's why you need to do this. Else we're going to do pygame.display.update. That's going to update. So this is a basic a basic structure of how our Pygame file is going to look like. Then we're going to now build on top of this. Now we'll start by defining our, we're going to, like, let me call them global variables. That's how you utilize capital letters. So as you can see from what we have in the file, so I'm going to say define all the color codes. Now at this point we're going to say black. We know black is a tuple that contains 0 0 0. We have white, this is going to be 255 255 255. We're going to say red, of course is it. Okay, let me just add something. Let me add something so that you guys can see. Now the color tuples utilize the RGB system, i.e. red, green and blue. And how do this work? So each of the colors can have a value from 0 to 255. So each of them can have a value from 0 to 255, where 0 0 0, where we say 255 is the primary, let me just say the primary color, and the values in between, aside from 0, we're just going to call them variations. Let's say form different color variants like that, of those 3 primary colors that we work with. So if you didn't know like what we're doing, that is basically this tuple. It's an RGB. So basically the tuple, so let me say the tuple is defined as, we're going to say the tuple is defined as, into brackets, red, green, blue. Then we're just going to say within this, it's not typically, but it's going to be value x. We say value x, value y, then finally we'll have value z. Let's say z. So and where, so that is basically what is happening, where x, y, z are values. So I'm going to say, how do I define it? So let me define mathematically, it seems easier. So I'm just going to say where it's usually no, not there. So why did I forget that? Anyway, let us see. So we are going to define where x, y, z, where these values are simply within a given range, and we've defined that range where these values are greater than or equal 0, so or less than or equal to 55. So I hope you understand what that means. You can't have negative values, that's values below 0, and you cannot have values above 255. So that's how we define color codes in what we're doing. So let us continue defining the rest of our colors. As I said, is RGB, so red is simply going to be 255, then the rest are going to be 0. We're going to have green, red, that is the opposite, that's being 0, 255, then 0, finally blue, which is going to be 0 0 0 0 255. So I hope you understand. 255 is the max color, which means this specific color is like 255 represents those 3 color codes. So if you have red being 255 max, green 255, blue 255, then you have white. But if you remove this other color, so it's like you're not mixing them, and let's say for red you have 255, green and blue have 0, you have now the red color. So that is basically what you're doing here, simply just tweaking with the XYZ values to get the appropriate color. I'll also show you how we'll convert this later, how we use opacity or transparent colors. So I'll add that quickly, but comment it out. I'll say window.convert alpha. So we need this class. We'll need this class sometime, this to make the colors work or be transparent. So that allows us to utilize so I'll say this allows us to extend the color palette to include what we call an alpha. So the representation of this, the representation of these color codes extend with an A, i.e. No, let me just do undo. So this extends, let's say this extends the color palette by introducing opacity to the color codes. So then I'm just going to say an IE representation of this is going to be RGBA, like that. So it's going to be X, Y, Z, then value N. So value N is the opacity. Let me just update this, say Z, Y, X. This is going to look like. You see, so yeah, that is like an example of, I'm just extending that as you go through this file and write the code. It would be nice to follow along. I mean, you should be able to see something, but basically that is it. After we define our color palette, now this is where things take a turn. So the first thing you'll see as part of this file is the next step was to draw the surface. So what he simply did was fill the entire window with white. So what is white? White, as you know, is the color defined. So instead of passing the color code, we can simply pass the variable white directly to make it easy. Then he did use the Pygame object to draw things within the surface that we've defined. So in this case we have the polygon, but you have to determine where is the polygon being drawn. In our case, in the window. So we draw the polygon in the window. What is the color of this polygon? Define the color. That is like that. Then you can see we have like when you hover in your editor, you'll have this option. So it will show you the parameters expected by that particular function. So in this case, what are the parameters expected? We have the surface. We've defined our surface, which is our screen. Then we have the color value. We've defined it RGB format, the tuple. For in our case, we went with blue. We can change that color. Then we define now the points. So what is a polygon? What is a polygon? So I feel like this is an object with more than in this case we have 1, 2, 3, 4, 5. So these are 5 points. And a polygon is a shape that I think has more than 4 points. So kind of like heptagon, hexagon, those are all polygons. So we can draw any by defining the various metrics that we need. So we have the sequence. As you'll see here, this is what is passed. Let me just borrow this to make it easier for us to draw. Or okay, what you can do is, yeah, instead of drawing a polygon, let's find something that makes it way easier. Let's just draw something. So we're going to draw, let's draw a circle. We're going to draw a circle. Then it's going to be inside our window. We also need the color value. let's make a circle red. Now after that we need the center coordinate of our circle. So in this case we're going to do 300, let's say 50. Then we're also going to have the radius of the circle, as you can see on the screen, and then the width of the circle. So if we do not pass the width, by default it's going to be 0. So I'm just going to say the radius is going to be 15, and then the width pass 0. How that is how we draw the object. And this Pygame display.update, it's now what's going to refresh our UI and then subsequently show us let me see. I see. And subsequently like show us the screen. So we are going to like run this very quickly. Let's see. Let me just close that, open. Going to say projects, learn Python, vn learn Python. I'm going to say source vnv being activate. By activating that, I'm going to do Python 3. What is the name of our program? Let me just cannot switch with commands. Drawing.py. Yeah, and as you can see, we have filled our screen with white, and then we have the red circle. We can also further update it so that you can see, instead of filling it with white, let's fill it with black. Let's say black. Then just write that black. And I think, okay, we need to restart it with those changes every time, but we're going to get to a point whereby I'll demonstrate we actually don't need to. So let's see, do that. Yeah, we have now the black, but okay, white makes sense for most people, so I'm simply going to go with white. Now this is what we have. Yeah, we can also draw other things. This is a simple drawing for what you have. As you can see, as part of the example, you can draw almost anything. By defining specific pixels and positions, we can also utterly update anything. You can draw a rectangle, as you can see, rectangle, the surface, the color, then the dimensions, x, y, width, height. Same with the ellipsis. The surface, the color, x, y position, then the width, height, and then I think this must be the radius. Yeah, so that is how we define most of these things. The same thing with the line, because a line is joining 2 points. You only need to define, after the color, you need to define the xy position for point A and the xy position for point B. So xy position point A, point B, then those two will be joined, and this is the length. You can also specifically define the length. You can also check an easier way to, like, instead of trying to cram this, you can just simply do a pygame.draw. Let's say we're drawing a line, then within you'll see the surface. We'll pass our surface, we'll pass our color to be green, then you should see starting position. So the xy coordinates, and as I said, xy coordinates are defined in the form of like tuples. So if we say we want it to start at 20, then comma, you'll see the ending position. So from 2020, and then the width. So let's say we want our line to be 4 pixels, let's say 5 pixels long. So we can calculate 2025. So from 2020, so at position 20, that is x top left, that is 20. Yeah, so that is the coordinate of top left, then or the specific pixels that we want. So can say 2020 to 5050. So So you can say 2020 end position 50 50, then what is the size? So we'll say, let's say 5. So we've drawn a green line. Drawn a green line. So keep on forgetting this. Let's save. Yeah, so if we run a command once again, you should see this is the line. So you have that. So this is the like width or thickness of the line. What you have here, the 5. But if we change it to like a different color, you should be able to see let's say nothing. It will take a default size. Then let's switch clear. Yeah, you can see it's now thin. That is the width of the line, but we have the tuple 1 to define the first or starting point, tuple 2 to define ending point. So that's why you have that. Let's say we want to draw it a straight line, because right now it's a diagonal line. So if we want a straight line, we can use simple mathematics. We can simply ensure they're on the same horizontal plane. Like, I hope you get that. So the x coordinate for the starting point is 20. So you can actually like and the y coordinate is 50. So we can place these two at the same y coordinate, so that the height, it doesn't like go down, stay on the same horizontal plane, but the vertical distance, that is what changes. I think that should work pretty well. Just going to test it out, do that, then run. Exactly. So you can see we have that line appear there horizontally. Vertically, you can also do the same. We're simply like retaining, sort of like just playing with mathematics. How do you define your horizontal plane, the xy values? So if we wanted it to be vertical, we'll do make this 20, then change the position of this to like position like 120. It's 120. Then we're going to have to save those. We come back to our project, clear, run. Yeah, we have the vertical line. So it's simply manipulating positions, and once you know the draw object and the various functions it provides, you've defined your colors, you can create a pixel, then it should be okay for you to for example, let us like try something. Let us try to draw something and see how it goes. So we have like these lines. So we'll want to join these lines to form, let's say we want to form a rectangle using lines only. I think that's autocomplete. Okay, so let us say we want to draw a rectangle using lines alone. You can simply do that, pass the window object, make it also green. Then for the tuples, if let's say right now I have the vertical line, right? If we wanted to have another vertical line, we simply have to move the x coordinates, right? I think that should like make sense. So we're going to move the x coordinate, but the starting point, or the starting point for our new vertical line at the other end, is simply going to be the ending point of the previous. So you're simply going to have 20, 120 as the starting point, for that, and then it's going to like we're going to like bring it down. So so we have like this the starting point of this line, then this the ending point. So that's what makes it vertical. So it's the starting point. You can see the x variable, the xy, the x position stays the same. So for our new line, we might want to move it, let's say, to around here. So you're not going to do that. Instead, we're going to say we're going to move it by some distance, the x value. So we're going to say the other line will be at let's say it's going to be at 60, so let's say it's going to be at 60. Then the ending point for that should be let's say 60. We're going to say 60 but 120, so that the height remains the same. So I'm thinking something along those lines, not really sure, but we're going to test it out and see whether it does the magic. Yeah, so you can see we have this, but the position is different. So I was right, we need to change, we need to come here, then I'll say it's also going, so we're going to say it's also going to be on the same plane, not 60. So it's not going to move down at the y-axis, but it's just going to be 60-20. So small distance from here, but instead of 60, let's say let me say like 120. That is the starting point, right? Then the ending point should also be the same, because we want it to be like on the same x-plane, the new line. So it's going to be like 120, then move it down 120. I think that should suffice in terms of having our two lines on point. Clear then. Exactly, so we have two vertical lines that are equal, that formulate the basis of our rectangle. You can also now add something new. Let me just check that. We need to add like something different. Now we need to add the two lines that should cover the tops, right? We need to add the two lines. So we're going to say Pygame. No, I think this is wrong. So we're going to say Pygame dot draw, and to draw a line, but in the window color green. But now for our tuple, this was something changes slightly, because it started at 2020, no problem. So we're going to have the same starting point. It's going to do 2020, but for our first top line, the ending point, that is now where we're going to shift it to make it, instead of it being vertical, it's going to be horizontal, right? And this other ends at 120, so it's going to be, we're going to invert 120 20, right? So it's going to be 2020, but the vertical, we need like the horizontal plane not to move. It's going to move from 20 to 120 to cover the top part. And for the other line, it's going to be pygame.draw.line. Going to pass the window object, pass green, then also going to have the same starting point, that is 120 and 20 then the ending point. So the y-axis is not going to change, right? The x is not going to like change. So for this, going to start at x 120, then it's going to end at because the x value moves from position, okay, from position 120. Let's see going to be on 2020, then 2120. So this is going to be also something, no, so this is going to be 2120. It's going to be 2120, and it's going to end at so 20 there's going to end at on the same plane. So I think that should be 20 and 20. Let's see how, what appears in case of anything. We're just going to update that. Clear. So yeah, we have this line, but it seems both lines appear the same lane. So it's like we have the same line. Let's see. So this other line is dependent on like, so we're checking the position of the vertical line, right? Because you have the first line or the first vertical line that is like the 2020 position 2020, so x will move nowhere, but the y will come from 20 to 120. The next line you have, it's going to move along the x-axis 120. The x is going to stay intact, but it's going to get from there to now bottom. Then the new top line is going to be at position 20, then it's going to be at position 20, right? So the same position as where the line started, 2020, and then the x is going to move from 20 all the way to 120, but the y, but the y is going to like remain intact, so it's not going to go down, instead it's going to move along the plane. Then this other line, because remember, this other line should start from 20, 120, this position, and then the x, I see the problem. Then the x should move from 20 to 120. So the issue was at this point, 20, 120. So I'm going to say this is, let me just try and label them. This is, so how do we label them? I'm going to say this is the left side, so this is the left side, then we have the right side, so those two, because as you can see the x plane does not move. Then this is the top part, then we're going to say the bottom part. So yeah, we've labeled it, but I think should be fine. So the next time we test this, we expect, okay, so there's also another issue. I think we had, let's see, so the starting point works for the bottom part, that is 20, 120. But the x plane, the x plane should move. I see, so it's going to be, I see the problem. So from x going to move from 20 to 120, but for y is supposed to retain the same plane, so it's going to be 120 and 20. Now that should be perfect for us drawing. Now we have a pretty perfect sort of like square. You can say this is a square, but anyway, that is how you can achieve a shape or manipulate simple line functions to actually come up with different shapes. You also saw we have the pixels. We're going to use that when dealing with actual sprites. It's going to come in handy. So this is an outline of everything, what fill does for the surface, how to draw a polygon at the different points in a polygon, so the xy coordinates. So for this I think it's a pentagon, because you see xy point 1 2 3 4 5, that's a pentagon. So those are 5 points defined, and then they'll be joined together to form that particular polygon. Lines, you simply have point A to point B. Circles, you have for circles you have, of course, as you can see, we have it explained very well here. Circle, we have the surface, of course, the color, then the center point. So what is the center point? Then you define the radius and then the width. So the width, you also define it here. Same for ellipses, bounding rectangle, the width, and so on and so forth. We see Pygame pixel array objects. Unfortunately, this you can call that will set a single pixel to a color unless you call the drawLine object with the same start and end point. I think that makes sense. So it's going to be like a dot. So it's simply going to color that specific pixel, because your start and end points point to the same origin. But instead, you can create a Pygame pixel array object. for short. Okay, let me add that to my notes. I'll say to manipulate a single pixel, we use pygame.pixel array object. Yeah, it's an constructor, basically constructor function. It's a constructor function, but it instantiates the object. That's why it's called simply an object. Of the surface, set individual pixels, creating a pixel array object of surface. We have that. Functions can still be called, but it cannot have images like JPEG, bleach. So we are going to encounter by this bleach method ahead and see what happens. See, is locked, get locked. You have that array, then you have the xy coordinates to be black, remember. That's the tuple. Yeah, we have display update function. So when changes are made in our program, this function runs and then we get the updates. Next, animation. Right, so I think I'll just do up until animations, then I'll see whether or not we'll have another session. Number one, you need to understand critically how animations work. Okay, if you're looking at it from a different standpoint, simply an object moving from position X to position Y, and you'll see after I'm done, let me just start here. Now that you know the framework to draw screen, let's learn how to make animated pictures. A game with only still and moving images, of course, will be dull. Animated images are a result of drawing an image on the screen, then a split second later drawing a slightly different image on the screen. So it's simply frames on the screen, what allows for pictures to be converted to motion. You see, so like pictures be converted to motion because they're being loaded at an extremely high speed. So it seems kind of like how the old animations used to work, Tom and Jerry. Yeah, or if you've seen a flip book, then you know how animations work. So imagine the program's window is 6 pixels wide and 1 pixel tall, with all the pixels white except for a black pixel at position 4, 0. It would look like this. Exactly. So you have like, that's the size of the screen, but you have that dot. So if you change the window so that 3 zeros black, or the next pixel before that was black, then it would look like it will move a step. Then if you keep on iterating, it will move a step. But if now these things happen rapidly at a high speed, it feels like that dot is moving. So if you had a flip book, you'll actually see as if the dot is moving from point A to point B, because like the flip book, you're flipping it at a rapid pace or high rate. So it may look like a black pixel is moving, but this is just an illusion to the computer, showing 3 different images that each just happen to have 1 black pixel. Consider if the 3 following images were rapidly shown. So note the term rapidly. You see, that is the whole point where you hear a device is 60, it supports like 60 FPS frames per second. So that is how fast those images are shown on the screen, creating the illusion of motion, and subsequently that is what we register. Same case of how cameras work when you record content. But for the computer, it's simply like rendering just the images at a rapid pace. So here's a program demonstrating a simple animation type. Okay, so we're going to like have a new file. So this new file, I think we're going to do so we're going to say animation.py. That's our new file. In this new file, let us first import everything we need. We need Pygame, we need system. Let's say Pygame .locals, import everything. then we're going to see pygame dot initialize, then we're going to say animation, so let's call it animation screen, pygame dot so we say display dot set mode, define, let's say 500 by 500, set our caption as pygame dot display dot set caption animation example. So this animation example we have like that. Then our usual while, so while basically through the game loop for check for the event in a pygame dot event dot get, if check if event dot type equals quit, then definitely pygame dot quit, then system dot exit, else we're going to update the display, say pygame dot display dot update. So this formulates the framework of our animation screen, but now we'll continue the rest of the code that now defines exactly how we create a simple animation. So it's called cut animation. It will require the image file cut png. Okay, png to be the same folder as cut animation. You can download the image here, open new tab. Okay, let us so call it just cut, but let us save it within the right space network, so we can't. Okay, let's just paste for now, we'll see how it goes. Come back to this folder, then into home, Nimrod, let's get to projects, learn learn Python. So within this, that is, we're going to move our image. So we'll copy our image, get back and paste it. Yeah, so you can do a quick check just to be sure. Okay, we have our cut image there. So we'll continue with writing a script. We have that initialized, then so we'll define the number of frames per second. Ideally we are going to go with 30 standard, because our eyes cannot even comprehend, like, let's say 60 fps, 120 fps. That's why if you hear a lot of people game, they just say it's smooth, but you cannot see the difference or comprehend 30, like 60 fps, because that's too fast. The number of frames being loaded per second, that's too fast. So we're going to go with the moderate 30, which also works best for a lot of things. Then I think we need to define now our time or our clock. So this is going to work for whenever, to track every second. And we have now our display, we set our caption initially, then of course I forgot to set so let's say animation screen bg. I can do this and then just say 255, then come down and say animation screen dot fill, then say the background. The cool thing with Python, we can definitely do this. Okay, next we have so we have that. Then what else are you going to do? Now we need to load the image into Pygame. So as you can see, part of the instructions to load the image, so we're going to say cut image, it's going to be pygame dot image then load the image. What is our image? I think we have it already, so cat.png, also have it within this level. Then the position, so what is the position of, or the initial position of this image? So for the example, it starts with xy1010, so we are loading the position of our cat. Then what direction is it facing? I think what this is going to be to do, because I'm thinking a direction left or right, because we're simply going to flip the image or rotate it based on which direction, let's say, we want it to face. Kind of like that is how sprites work, because you get a sprite, sometimes the user actually defines, or the owner or yourself, you can create a sprite for your character facing right, your character facing left, your character walking. But there are cases whereby the sprite utilized kind of like feels the same, so it looks the same. You see, it looks the same in neutral. So the cheat sheet sometime back was to simply switch the direction. So if you're clicking right, flip the sprite the other side, clicking left, flip the other side. But these days, instead, we can listen to those events and we have specific sprites. So we have character facing right, character facing left. For example, if I press space to jump, we have character jumping, character attacking, impact. Yeah, so that makes like work way easier. But for now, we're simply going to do that. And then in our while loop, you'll see the fill is done within the while loop to ensure this happens every time the game or the loop is on. So we can I remember the command to do this? Let's get into like visual. Yeah, so inside this we can I think we can delete. No, oh, okay, I see. So let's revert that change. We're supposed to do that for this. Delete that, move it. Let's move it like here. Going to. So yeah, we're going to do that. We're going to paste it. Then we have that. So we fill the animation. Then what is the next thing? Before this is the game loop. So for now we can simply say that is like by default you have to set up. Let me just like isolate it so that you understand. The default game loop and almost all Pygame project. So we have like that happening. Then we can now come here and start working on our logic. So you can see the first check is the direction. So we check if the direction of the cat is right, what do we do? Then you're going to see cat x plus equals 5. So this is basically we're going to like on the x coordinate for the current image of the cat, move it by 5 pixels. You see? Then we are moving it. Yes, we are moving it currently. But how do we determine whether or not this cat is down? Because you don't want it to go beyond the screen. So that is where this logic comes in. If cat we say to 80, but in this case they say to 80. Why? So let's see. I think I'll get the reasoning somewhere. Display load. Okay, let's just continue. So this checks to ensure the cat does not go beyond the screen, so it doesn't like go way up. So we're just going to set we know now our direction equals down. Then the next check, Python uses elif. I know most languages don't use that, but that is the convention with Python. So else if the direction is down, so direction is down, then we're simply going to also add plus equals 5. Then we're going to check if the position of the cat, so if down, of course we're going to check we're going to add the y-axis, because if we are moving it, like we're checking, want to move it across the screen. So definitely you have to check if direction is right, then x-axis by 1. If the x-axis pixels or the x-axis value is equal to 280, which means we've come short, then switch the direction to down. Once you switch the direction down, check if direction is down, then you're going down, add the y-axis by 5. But if that y coordinate is equivalent to 220, then switch direction. Direction is left, direction equals left. Then we'll do the same thing by checking elif direction. If direction equals left, if the direction equals left, then we're simply moving the opposite direction. I hope you understand. Like if you're moving right, we are adding to the pixel count from the current position. But if you're moving left, you're moving on the opposite direction. That's why we have the negative connotation. That's why we are subtracting from the position the cat is currently in. Because if we add it, will keep on moving to the right. So we need to subtract to bring it back. So let's say cat x minus equals 5. Then we check again. We check if that while it's moving back, we are now going to check that it's not, so that it doesn't go beyond the starting point. So that's why we're doing cat x equals 10. If that is the case, then we are switching the direction, meaning it's going up. I hope you get it. It's going up. Then do the check elif direction equals up. So if the direction equals up, what happens in this case? So we're going to now check the y-axis and subtract from it, because not going down, which is positive. So we're going to subtract 5 from that, then check if that y is not equal to the starting y coordinate. We're going to switch direction to right. Direction is going to switch to right. So that is the logic for movement, right? We have right, down, we have the left, up, etc. So that is what is going to define the movement for our respective cat character that we have within the root folder. Because remember, if you're going right, you're adding to the pixel count. If you're going left, you're subtracting from it. If you're going down, in this case, you're adding. If you're going up, you're subtracting. But you can also do the same as reverse, but it just makes sense. Then after this, we need to now display that image. We're going to display the image. So display the image on the surface. That is where the bleed object, this is not an object. So the bleed method, that is where it comes in. So we're going to say window, in our case animation screen. So we're going to say animation screen dot bleed. Then we're going to our cat image that we have and the positions or the starting position that we have, the variable that is constantly changing. So bleed will ensure within the clock time that we have, it will constantly update as our variables change. It will re-render or reapply the image within the surface. You see? So that's what is going to happen in that scenario. Then we have our own unique for loop that's just going to do every other thing like it's normal. So that is about it for like this program. Yeah, one last thing, remember we have the clock to track the frames, so also need to like define this. So you need to say and ensure like our FPS clock actually ticks, actually starts. Then you're going to pass our frame rate. So we're going to say we defined it as FPS, right? Yeah. So it will tick at our frame rate every, that is the 30 seconds that we have. Now we are going to run our program and see what we've done so far. Call it animation.py. You see, so it's now going to move. Once it reaches the end of the screen, you'll see it's going right, it switches to down, up, yeah, at that rate. So this is an example of a simple animation in Python, and as you can see, the frame rate of refresh rate is the number of pictures that the program draws per second. That's why I use the clock object within the time function or time, yeah, the time method that we have in Pygame. And on computers, the common name is FPS, of which I told you many people know. And these days, many monitors have 60 FPS or 60 Hertz. And a low frame rate can make the game look choppy. Of course, that is obvious for most of us. Yeah, so this is the purpose of this. All you need to know is that you should call the tick method once per iteration through the game loop at the end of the loop. So only once. Usually this is right after you've updated the display, you call now the method. So we can try updating this FPS count. Let us try to have, let us say 60. I want to see the difference. I'm going to do 60. I'm going to do like 60, that is that. Close. You can see, right? You can see like at 60 frames, it kind of like feels smooth because it's being rendered at the native resolution. Personally, for my monitor, if you have 120 Hertz or 120, your monitor supports 120 FPS, then that is also going to feel ideally extremely smooth. So it's going to switch positions relative to where it is. Right now, you can see it's moving within the bounds that we defined. So these are the bounds you see here. You see? So if it's moving in the right direction, you should see we're going to be adding a count of 5 or 5 pixels to its current position at the x-axis. Then we check. After you've added the 5, is it towards the end of our predefined bound to 80 pixels? You can add it actually as long as it doesn't go outside your display size, because my display is 500 by 500. I think the example used 300, so I can actually improve this and say for 80 pixels, that is for the x, that space. So it will take around let's say cut x for 80 pixels, or okay, because it starts at 10 minus that is for 90, give it 10. Yeah, for 80 pixels should work fine. Same to y. Currently it says to 20, but you can still also give it 480 pixels. This defines the bounds. You're simply checking to ensure that on the x axis, on the x plane and the y plane, it doesn't go outside our surface. So that's why after every change in positive direction, we are going to check whether it's within the bounds. But the other side, that is when we differentiate, because for that we're subtracting to the initial position. So once it's going back, or we're minusing, it's going on the left side, you simply need to check, is it at the starting point, right? And same applies to the y, and then you can now switch the direction to match where it currently is. So let me just save this, then come here, let's refresh and see. Yeah, you can see it works within the bounds. The problem is you can see like the image itself is kind of big, so we have to like limit and say, because we've not accounted for like the width of the image itself, so we have to slightly reduce this and say, I'm assuming, let me make an assumption of this is going to be around 380 for the size. I'm not really sure. 380, save, then do that. Exactly, perfect. So as you can see, that is an example of how to handle animations in Pygame. Yeah, this is the first session in many sessions, as I'll be taking the time to learn or relearn or go through one of my favorite libraries, Python libraries I've wanted to learn. And in the process, yeah, I'll share the journey with you, the coding process, the interactions, the tests, as I continue. And I'm also drafting notes, so the more I keep on doing the examples, I write down notes that might be helpful. So this is some of the resources. Once I'm done, I should be able to share with everyone. So yeah, see you.